So, ladies and gentlemen, let me teach you in this first and second subtopic types of what? Types of integration. And after types of integration, it will be easy for you to learn about symbols of integration, because the symbols of integration, we represent them according to which type of integrations that we are representing, right? Okay, so you say that in mathematics, science, and engineering, according to Sir Isaac Newton, and Beng, the German mathematicians, engineering, there are only two types of two types of interval. Two types of of intervals. These are, so namely, so the first one, we call it indefinite interval. Indefinite interval. And I'll tell you soon why do we call it indefinite interval and not indefinite integration. We can call it indefinite integration, right? You can call it indefinite integrations, but I'll tell you soon there's a difference, because there's a difference between integration and intervals. Integrals, they function. So in integration, it's a process of integrating. So that is indefinite integral. So we say that indefinite integral. So what is indefinite integral? That's the next question. What is indefinite integrals? So we say indefinite integral is the type of what? Of integration which does not have bound, or which is not bounded, which does not have what? Bound. So simply, it does not, or in other words, that to say that it does not have what? Limit, but means that means that it's taken into consideration from negative infinity to positive infinity, right? So this type of integrals, this is the integration symbol, right? We present in this way. So this is for the single variable integral, right? So for the single variable integral, this is the symbol, okay? So integral for f(x) dx. Okay. So again, we say that we have indefinite integral of the single variable. So you have the symbol of single. So this is 1.1 single indefinite interval. Single indefinite interval. Symbol of single indefinite interval, right? So we say that the symbol of indefinite integral is given as this. This is the symbol. So indefinite integral. So this is integral of f of x dx. So this one, we say that this is what we call in integral sign. And then this one is what we call it integrand. Integrand. And here we have variable of what? Variable of integration. Variable of integration. Right? Variable of integration. So this will be the notation, but that is in case of what? Definite integrals. But we can also have a symbol of integration. So symbol of integration. Symbol of integration of multivariable. Symbol of integrations of multivariable function. So here we have two types of function. The first one, let us start with double. So we are welcome into lecture 1 of one variable and differential equation for non-measures, and the topic is called the review of techniques of integration. So double integral. So in A level and honor diploma, we have never taught our students about double integral, but in undergraduate, higher engineering and scientific mathematics, we are going to teach you. So a double integral actually is the integral of the function which depends on what, of the function which is independent variable depends on what, on two independent variables. So here we have two independent variables. So what the symbol for this? So we have a double integral sign. We have a function of which depends on x. So it means that the function of x comma y, function of x comma y, dx dy. So that's the double integral. So remember that this is what it. So from this double integral function, because you have to keep enjoying, and here we have a function which is f of x comma y, dx dy. Wonderful. So this is what? This is integration. This is integration sign, right? And then here, this is what we call it integrand. Say integrand. This is called the integrand. And these two, x and y, we call them variable of integration. Variable of integration. I believe that you're enjoying and you are learning some new concepts, especially for the double integrals. I believe that every student who is watching this program has never heard about double integrals, or maybe you've been told by your advanced secondary teachers or your ordinary diploma teachers that later on you learn about double integrals, learn about triple integrals. So it means in that level, it's a moment where you have to learn simple integrals of the single variable integrals. Because if this is the double integral, we have to integrate it twice, right? Okay, so it means that this is the integration sign. Integration sign, this is the integrand, that's the variable of integration. So these are variables. So variables, plural, more than one. Variables of what? Of integration. This is what variable of integration, x, not d. This is changing x. D stands for the change in x. X is a variable of integration. F of x, it's called integrand. And this sign, this next sign, is called the integral sign. Right? So, and here also you have what? This is the double integral sign. So this is what? Double integral sign, or double integration sign. So simply say that in. So this symbol, ladies and gentlemen, represent what? Double integral. So this is representing double integral sign. Double integral sign. And this is what? Integrand. And this is what? Variables of what? Of integration. That is all about what? Double integrals. But another common multivariable function we call it a triple integral. Another common multivariable integral is called the triple integral. Triple integral. Triple integral. Triple integral. Triple integral. So it's triple integral. We say that we have this three single variable integration signs, so three integral sign, and then we have an integrand which depends on the three variable, for example, x, y, z. And this one we integrate it with respect to x, again integrate respect to y, then integrate respect to z. Stay tuned, the good news is still ahead. This one we have to integrate it twice. We have to integrate the integrals with respect to x, we have to integrate the integrals with respect to y. And also here, so it means when you integrate the integral with respect to x, we keep y constant. And then when you integrate the integral with respect to y, we keep x what? We keep what? Y integrand. For this case, we have three integral signs. Means this one, this one representing dx, and this one representing dy, this one representing dz. So we can integrate our integrand first time with respect to x while we have kept y and z constant. Then we can integrate our integrand second time when we are keeping x and z constant. So integrate with respect to y. Then we can integrate our integrand for the same time with respect to z when we keep x and y what? Constant. And then that's how we enjoy higher engineering mathematics, and that's how we enjoy the few techniques of integrations, and that's what we are adding in your mind on top of what we taught you in O-level, in A-level, and in A-level or in ordinary diploma studies. Wonderful. So with this notation or this symbol, it means remember that we are talking about symbol of what? So this is all about symbol of indefinite integrals. So indefinite triple integral, indefinite triple integral. So this one we call it sign of what? Sign of integral. Sign of triple integral. Sign of triple integral. And this one, it's a sign of what? This we call it triple function. It's triple integrand. Or simply called it an integrand. X, y, z. This we call times what? Three variables of integration. Remember, the word integration means process. Before, the word integration means what? Process. The word integration means process. Okay. If you have any question about this lecture, don't hesitate to ask in the comment section. Please interact with me through the comment section. Ask your questions as well as you can. Then just interact with me. Right? Give me feedback. You enjoy this content from which country, from which continent. So please let us interact in the comment section, please. Okay, so those are the common symbols and common integrals that you are going to deal in this course. The second type of integration, or the second type of integration is called the finite integral, or the finite integration, whatever the case. Okay, so we say that in mathematics, in maths, in engineering and science. The finite integral is the integral which have the finite or fixed bound. Simply to mean that it has what? Simply it has lower and the upper limit. And these limits, sometimes we call them boundaries. So this is the bounded integral. When you say bounded integral, for example, if you have a graph like this, let me speak mathematically. This is the graph, and this is y-axis, and this is x-axis. Then you have a graph like this. You have a certain graph. You have a certain graph. Okay, so this is what? Example, this is f of x. And then we can find the area bounded between point A and also in point B. So you can find the area bounded by the curve between A and B. Alright, so this we call the bounded or the finite integral. So it means we can find the fixed value, because we know this is the lower limit and this is the upper limit. And this is the graph for the single variable function, right? So now, can go into number 2. Let me teach you the symbol of what? Symbol of the finite integral. So the symbol of the finite integral is this one, but we have to add limits from A to B. Symbol of the finite integral is given at this one. So it means this we read as integrations of f of x with respect to x from A to B. So remember that A always represent what? Lower limit. Bear that in your mind. B represent what? Upper limit. Okay? So we have lower limit and upper limit. F of x is integrand single variable, or yes, it means it's a single variable integrand. Then x is variable 40 of integration. Then, ladies and gentlemen, let me take you into the symbol of what? Of multivariable integral. The symbol of multivariable integral. The symbol of multivariable integral. Okay? So the first thing that you have to remember is, means to say that the symbol of multivariable integral is, okay, is given as, so for what? For the double integral, this is a symbol of multivariable finite integral. So for the double integral, double integral, we say that we have integration from A to B, then you have integration from C to D, then you have a function which has two independent variable x comma y, and then here we have dx dy. So this is the symbol of what? Double definite integral. Double definite integral. Double definite integral. Double definite integral. So this one is the same thing. Okay, so but let me write. So from this symbol of what? Of double definite integral from A to B, then we integrate from C to D. We have a function f of x comma y dx dy. So this one, remember that these two signs are what? This we call them double integral sign. Listen carefully. Listen carefully. Everything that I'm teaching you, you realize its applications in near future of this course of one variable and differential equations for the non-majors, which is highly and intensively taught to College of Engineering at University of Dar es Salaam. So more than 700 in a year are learning this course in one university. But also it is lengthy in State University of Zanzibar. It is being lengthy in African University of Tanzania, it's called that the African United University of Tanzania. So it's been lengthy at St. Joseph. So it's a double integral signs, or double integral sign. Then this one, this is the function, right? So this function, we call it what? Double integral function, but here it stands, or it is what? Double integrand. And then we have x and y. These we call them variables of what? Variables of integration. Variables of integrations. It means that we have to integrate this function. So how do we read this function? It's an integral of f of x comma y from c to d with respect to x, and an integral of what? Of a function f of x comma y from a to b with respect to y. Remember that this integral sign relates with this variable, right? And then this integral sign relates with this what? Variable. So don't confuse. This stuff are not difficulty for the lovers of what? Of higher engineering and scientific mathematics. B. Then I would like to teach you about what? The symbol of what? The symbol of triple definite integral. Triple definite integrals. Okay? The symbol of triple definite integral. Okay? So you say that the symbol will be a little bit interesting. It's integral from, and then here I forgot to define. A, C, these are what? We call them lower limits. Then what? B and D, this we call them what? Upper limit of integration. Very important, because that's what bound the integral, the functions, or the area under the curve. So here we have to integrate from A to B, then have to integrate again a triple variable function from C to D, then have to integrate again from E to F. Our triple function, f of x, comma y, comma z, and you have the x, you have the y, you have the z. Okay, that's the triple integral side. So ladies and gentlemen, so you see, it's just the first lecture, but I believe that you are beginning to enjoy a new concept in one variable and differential equation. Isn't? Tell me in the comment sections. For me, I've never learned this stuff in my A-level education, and also when I was doing my undergraduate studies, I studied with some ordinary diploma students with some students who did ordinary diploma engineering in different engineering programs, or in electronics in programs, in electrical programs. So I studied with them and I asked them, they told me also they've never seen these symbols. Okay, so this is the triple integral function, triple finite integral function. Okay, so if you analyze this symbol, we have 3 integral signs, we have 3 lower limits, we have 3 upper limits, we have an integrand which depends on the 3 variables x, y, and z, and we have 3 variable of differentiation, or variable of integration. All right. So for that case, we know that this symbol presents what? This symbol presenting triple the finite. So remember that we are still talking about the finite. So triple the finite or finite. So it's called the finite or finite. And the rest is called the indefinite or infinite. Okay, the finite, a triple the finite integral sign. Integral sign. And then this function, very interesting function. This we call to what? So this we call to function of what? So we call it function, call it triple integral or triple function. Triple, this is not, okay? So this we call it triple integrand, but simply you can call it this is integrand of the integration. Then here, ladies and gentlemen, we have x, y, z. So this we call them what? Variables of integration. Variables of integration. So A, C, and E, this represents what? Lower limits. Then have what? B, D, F. This will have what? Upper limits. Upper limits. Upper limits. Upper limits. Okay, ladies and gentlemen, those are the 2 types of of integration, and then these are the symbols for single variable integrals and multivariable integrals. All right. If you have any question, let me know in the comment section. So ladies and gentlemen, we say that let us deal with in the finite integrals first, then we'll come up to cover about the finite integrals later. And this is why this model is called one variable, because we'll be dealing with single variable integrals itself. We won't deal with this, we won't deal with this. So this double integral, triple integral will teach you in another course that we call in another course that called the several variable calculus. So don't get confused. We'll teach you this because it is much used in engineering and science. So stay tuned and keep watching videos in our channel. So let us focus on indefinite integration. Indefinite integration, or we call it what? Infinite integration or indefinite integrals. And right now, before even we proceed with this, we say that the reverse operation the reverse operation of finding. The reverse operations of finding a derivative is called the antiderivative, or finding derivative. So the reverse operation of finding derivative is called what? It's called the antiderivative. So the reverse operations of finding a derivative is called the antiderivative. So we say that, for example, if we have been asked to differentiate a function f of x in capital letter of the single variable, then we may get a new function that we call f of x. Okay? But remember that I told you, if you take the same equation, this is equal to what? Is equal to f of x. So this one is dx, and this one is dx. So dx and dx cancel. So d of f of x is equal to what? F of x dx. Right? So for that case, you say that d of what? Of f of x is equal to what? F of x dx. So if we integrate on this side, you'll find that we get the integral, which is a function f of x is equal to integral of f of x dx, but f of x is the derivative. So now we have a certain challenge there, that in most cases, or mostly functions, or means the last term for the mostly function, or for the so many function, is used to be a constant. It's used to be what? A constant number. Let me repeat. I say that when we are integrating a certain function, it means if you have f of x, and then we're given a certain function f of x, if we integrate this function, we might have so many or millions of results. How and why? For example, find the antiderivative Find the antiderivative of what? Of the function f of x is equal to 5. Find the antiderivative of a function f of x is equal to 5. Means you find the integral. Find what? The integral. So you say that to find the integral while the function is that one, so you say, for instance, for this case, say solution, you have to recall what? You have to recall the formula. And if you're integrating, but you find the finite integrals, you say that if you're integrating a certain function f of x in dx in, then we get a new function f of x. So we have asked it to integrate f of x. So integrate f of x with respect to x, you believe that the response will be f of x. Right? Then here we are. We integrate what? 5 dx. So by using laws of integration, this is 5 integral of what? X power 0 dx. In other way, this is 5 integral x power 0 is 0, it is 1, so dx. So listen carefully. So once we integrate there, say okay, so here we get 5. Then there we get what? X power 0 plus 1, or 0 plus 1, for instance. So this is equal to 5x. But there's a second part, that if you differentiate 5x, we get x. But also if you differentiate 5x, so possible answers. Okay? So possible answers. So you say that if you integrate 5 dx, the response might be 5x plus 1, for example. Another possibility, the response may be f of x or 5x plus 2. Then we have 45 of x plus 1 plus 3, etc., etc. So that's what we say in higher engineering mathematics. There are so many what? Also 5x plus 2, 5x minus what? Minus 7, etc., etc. But that is not the case for that function itself. There are so many functions in daily life, in our daily life, that's how to work in that level. So it means if you integrate 5x, there are so many possible responses. Okay. Another example, find example star, find that derivative of f of x is equal to x squared. Find antiderivatives of what? Of f of x is equal to what? X squared. Is equal to x squared. Solution. So you've been asked to find integral of f of x is restricted to dx. So if that's the case, this is equal to integral of what? X squared dx. Okay? So if you integrate x squared with respect to x, you say that this is x power 2 plus 1 and 2 plus 1. So now integral of x squared dx, this is equal to what? Is equal to x cubic over 3. But it is not the only function that when you differentiate, we get x squared. Mean that now this might be one of the response, but also you can have x3 over 3 minus 4 can be maybe x3 over 3 plus 6, etc. So you have so many responses. So these are possible responses. And also this one, now all of these are possible responses. So say that so in the finite integrals, so in the finite integral generated, so generates of the finite integrals generates so many possible responses. What does it mean? If you differentiate this function, its answer is equal to, if you differentiate x cubic over 3 minus 4. So the same response, the same derivative. And even if you differentiate this one, you get the same derivative like this one. So then in the finite integrals generated so many possible responses. Okay? So how can we figure out this challenge? You've been given a theorem in mathematics. And this theorem reads that if a function has more than one antiderivative, then the antiderivatives differ by at most a constant. So then 1. If a function has more than one antiderivative, has more than one derivative, if a function has more than one derivative, then the antiderivative, then the antiderivatives, then that derivatives differ by at most a constant. differ by at most. So if a function has more than one derivative, then the antiderivative differ by at most a constant. So what are we trying to do in this concept of what? What are we trying to deduce here as engineers for scientists? Is you're trying to deduce the reasons we add the integrating constant when we integrate in the finite integrals. So the aim for that case, we say that we have now we have now a concept that we call the concept of what? Concept of integration. So most constant. So it means that simply, in order to, or generally it means that we say this is integration constant. For representation, of what? Excuse me. Okay. So, ladies and gentlemen, we say that for representations of what? For representation of representations of several values, of what? Of integration, for representations of several variables of integration, so the result of integration contains what? Contains a symbol of constant. This is C. What does it mean? If you integrate the function f of x dx, okay? So if you integrate this one, then you get maybe a certain function f of x, but always because we don't have limits, we add c. C representing any number. For example, in this equation, C representing 1, this equation C representing 2, so this equation C representing 3, here is C representing negative 2, C representing what? Negative 7. Wonderful. So it means that this is the general formula for indefinite integrals. Also, but remember, for indefinite integral from a to b of f of x comma I dx dy. No. I don't want to confuse you. Generally, we say that integral of f of x is equal to f of x plus c. So this is the general indefinite integral that we are going to deal with. Okay, ladies and gentlemen, this is the end of lecture 1, titled as what? As the finite and indefinite integrals. At least you did the quick review and we added new materials for you. And we gave you reasons why we are doing this in mathematics in order for you to enjoy. So ladies and gentlemen, this is the end of lecture 1. I would like to invite, I thank God, I thank my father who is Neville, for the great thing that he has done to me before these sessions, at these sessions, and even later on. And I thank you because he's going to teach you understand this concept without too much of hassle. So may God bless you until we meet in the next session. But I'd like just to remind you about your seed offering and free will incense giving. Then we keep on offering. So the telephone number 0759745331. And the free will incense giving will be used to support the programs. We used it for recording, we used it for transmission. So that's why that we have to ask you that to follow those steps for you to be a part of. Right? So that the point that I wanted to make. So if that's the case, you say, okay, fine. So we say that this is the finite integral, this is the definite integral. Okay? So that's the case. So again, you have to remember that to write in the comment section whether you've understood it or you have something else that you want to add. So whatever the case that you feel from your heart, you can do in the comment sections, and we use to read the comment section of each video. So may God bless you. This is the OLENJOLAI from beautiful country, Tanzania. Then see you in the next session in order to break down the concepts of what? These concepts of who? Review of techniques of what of integration. Wonderful. So may God bless you till we meet in the next session, and we'll keep enjoying everything that will be delivered to you. Right? There's no homework for this lecture 1. We have homework lecture 2, so that you can take practice yourself as long as you can. So may God bless and keep you until we meet in the next session. Keep enjoying high engineering and scientific mathematics.